Hi, it's Bentley's mom. We're going to do chapter 11, lesson 5, using the mean, median, and mode. So how to know when to use which measure of central tendency. To use the mean, you want to use this when there's no extreme values or outliers. So if you have your data set and it's in order, if you have really extreme or like really high or really low numbers, the mean, you have to add them all up, and so that will throw it off a little bit. And for the median, which is the middle number, remember when your data is in order, you want to use this when there are extreme values or outliers and there's no huge gap in the middle of the data. So if you have outliers here and there, the median is a good measure to use because when you come into the middle, it doesn't include the really big and the really low numbers. And so also if there's no space, really big gap in the middle, that when you get to the middle, it's a pretty good measure of the data. Then mode is if there's a bunch of repeated numbers, that could be good. For mode, I also want to look and see, if something only repeats twice and it's kind of an extreme value, you don't want to use that. But if it's, in the middle and there's a bunch of repeated numbers, then the mode's a good measure to use. Okay, so we're going to do some examples. Okay, so we're going to do example 1. I'm on page 846. It says the table shows the number of medals won by the United States. Which measure of center best represents the data? Then find the measure of center. So in this example, I like to put my data in order. So we have 97, 101, 103, 110, and 112. Okay, so if we look at this, I don't really see any extreme values here. Where you have 97 to 112, they're kind of all around 100. There's not 3 or 500. There's no extreme values here. So I'm going to go ahead and use the mean. That's going to be our best measure here. So to find the mean, we're going to add all these up. So I'm going to do 97 plus 101 plus 103 plus 110 plus 112. And I get 523. And we're going to divide that by how many numbers there are. 1, 2, 3, 4, 5. And 523 divided by 5 is 104.6. Okay, and so that's the best for example 1. And I would say something just like, if you have to explain it, just the data has no extreme values and there's no numbers repeated, so we wouldn't use the mode. So our mean's our best bet here. Okay, the next one, example 2. It shows the water temperature. I'm going to put that in order. This is example 2. This was example 1. We're going to do 78, 81. Then we have 82, 82, 82, 82. We have 4 82s, or maybe 5. Let's see. Let me count. 1, 2, 3, 4. And then we have an 85. Okay, so in this case, I have 4 that repeat, and they're in the middle of the data, so I don't really have to do any calculations here. I'm going to use the mode. That's a really good measure of this data, and the reason is because there were 4 numbers that repeated. Okay, let's turn the page. Go to example 3. Okay. Now, example 3 says, okay, there's a table that shows the average lifespan of some animals. So let's write this. I'm going to write it in order. So we have 20, 30, 30, 35, 50, 70, and 200. Okay, so in this case, it says identify the outlier. So clearly you can see it goes from 20 to 30, 70, and then 200. 200 is a really extreme number for this set of data. So 200 is going to be our outlier. So the outlier is 200. And again, an outlier, I always say it's outlying in the middle, like way out there by itself. So that's 200. It's a really big value. And then it says determine how the outlier can affect the mean, median, and mode. Okay, so let's do 2. We're going to do, this is number 4. We're going to do the calculations with the outlier and then without the outlier. So with the outlier, which means we're going to include the 200. We're going to use this whole data set. We're going to find the mean, median, and mode. So let's first do the mean. So to do that, I'm going to do 20 plus 30 plus 30 plus 35 plus 50 plus 70 plus 200. Okay, and when you do that, you get 435. And you're going to divide it by how many numbers there are. 1, 2, 3, 4, 5, 6, 7. And 435 divided by 7 is going to give me 62.14. And then in this example, they just estimated to 62. Anytime you estimate, use I call it the squiggly equals. It's actually the approximate sign. Just use that. So here's our mean. This is with the outlier. Now, when we do the median, okay, we're going to go 1, 2, 3, 1, 2, 3. We're going to find the middle number. So the middle number here is 35. Okay, and then the mode is a number that occurs most often, MO, mode, and MO, most often. And that's going to be 30 because that occurs twice. Okay. So that's with the outlier. Now we're going to do the same things, the mean, median, and mode, but without the outlier. So we're not going to include this 200. So we're going to pretend the data set is just that. Okay, so I'm going to do 20 plus 30 plus 30 plus 35 plus 50 plus 70. And then when I add all those up, okay, I'm now going to divide by 1, 2, 3, 4, 5, 6, because we're only using 6 numbers, okay? So when you add that up, you get 235. Can you see this, Bentley, on the video? Mm-hmm. And you divide that by 6, and we get 39 for the mean. Well, we get, approximately, I'll use my squiggly equals, 39. Okay, that's our mean. Now for the median, okay, we're going to go 1, 2, 3, 1, 2, 3. It's going to be in between 30 and 35. So remember, when there's a tie, you add them up and divide by 2. Or take the middle of those two numbers. So our median here is going to be 32.5. Okay, and then our mode is the one that occurs most often, which still is 30. Okay, so when we compare these, if you look, when there was an extreme outlier, the median here was 35, and the median here is 32.5. They're different, but they're just slightly different. They're still in the 30s. And then the mode actually didn't change. It's 30 here and 30 here. But notice how the mode and the median are in the 30s here and here. But with the outlier, look at the mean. The mean's 62. Okay, that's not in the 30s at all. That's double what's in the 30s, right? That's in the 60s. But here, the mean is still in the 30s. It's 39. It's a lot closer. So if we notice that when there is an outlier, it's which one's affected the most out of the mean, median, and mode, the mean is way more affected, okay? Because you have to include that number. Whereas when you're doing the median, you kind of go like this. The really big and the really small numbers kind of get left out. It might shift a little bit here, but in general, what happens, and this is a very common standardized test question, they'll say if there's an outlier, which measure of central tendency gets affected the most? And your answer is going to be the mean. Okay, so we can see the mean was affected way more than median and mode. Okay, and sometimes median doesn't get affected at all. Sometimes it does slightly, and then the mode shouldn't get affected because an outlier wouldn't be the mode. An outlier is like one number by itself, or maybe two. But if something repeats over and over again, it's not going to be an outlier. Okay, and I think that's it for the explanation. Okay, come back with your homework. Bye.